This is an extension on the quadratic equations but not on how to solve the equation, not on what the solutions are, but on the number of roots, how many roots are there. So these are all taken from the DSE past paper questions. So the first one, we have x between 0 and 360, all right? And how many roots are there for this equation? 7 sine square x is sine x, all right? Now, there are two things I want you to pay attention to. Number one is the range, right? It seems that it is just a trivial for x between 0 and 360, but we shall see later that it becomes a vital instrument in this in the solution to this question. And secondly, the thing not to do is not to cancel the sine x, right? Sometimes people may do this. So 7 sine square is sine x. So she cancel the sine x, that is 7 sine x equals to 1, all right? Now, but once again, it's very wrong to do it this way, right? If you recall the video on solving trigonometric equations, do not cancel the 0. If you are not sure whether what you have cancelled is 0 or not, then try not to do it, all right? Keep it like this. Keep it like 7 sine square is sine x. So instead of cancelling, maybe it is a better idea that you collect all those terms into one hand on the one side, all right, equal to 0. And then you do a factorization. So you have sine x times 7 sine x minus 1 equals to 0. So now you see there are two possible solutions here. It's either sine x is 0 or 7 sine x equals to 1. All right, 7 sine x equal to 1. Or 7 sine x minus 1 equals to 0. But anyway, this one goes to sine x equals to 1 over 7, all right? So we can use the calculator to find the answer. This one, x will be like 8.21 degrees, all right? This is the answer from the calculator. And then when sine x is 0, x is 0. All right. Now, but we know that for inverse trigonometric function, there are extended answer to this one. If the parent function is sine x, then we have 100 degree minus, 100 minus, or 360 plus, or 360 plus, 360 plus, all right? And it is 100 minus the answer from the calculator, 0, or this one is 8.21, all right? So we have the answers like this. We have answers like x is 0, 180, or 360 coming from this stream, all right? And then we have two more answers, 8.21 or 180 minus 8.21. That is 171.79, all right? And that 360 plus 8.21 is 368, and that is out of range, all right? So we do not use this one. It is out of range. All right. So now we can see all together. Now there are 0 and 360. You have to see the range. That's what I say. The range now is very important. All right. If you look at the range here, the range include 360 and also include 0. So these are both acceptable answers. 0 is an acceptable answer. 180, 360, 8.21 and 171.79. All right. So altogether, there are 5 answers, because both 0 and 360, they are included in this range. All right, so that's why it is important. If it were not just smaller than 360, then it goes down to 4 answers, because 360 is not included. Furthermore, if it is even like this, right, if both 0 and 360 they're excluded, then it goes down to 3 answers only. All right. So the number of roots depends not just on the equation, but also on the boundary. All right. Okay, so this is one past paper example on how to count how many solutions are there. Let's take a look at some other question very similar to this one. All right, so here for the top question, it is a quadratic equation, right? So we can factorize the quadratic equation. We have 5 sine x, then 4, and then sine theta and 1, right, is plus 5 minus 4 equals to 0. So we have two answers. Sine theta is 4 over 5, or sine theta is -1, all right? And we can find the answer from the calculator. Theta is -90, all right? And for 4/5, it is 53.13 degrees, all right? Now, not just that, there are extensions. We have 180 minus or 360 plus, all right? And we know some of them, they are out of range. They are beyond the range of 0 and 60, so we have to discard those, all right? We have to discard those that obviously give the answer out of range. All right, so this red number is the one from the calculator, okay? 180 minus -90 and so on. Okay. So here we go. We have these answers, right? The first one is within range, 53 point something. The next one is also within range. This one is out of range. This is out of range. This is 270, but they are the same. The second one is also 270. So both are the same, all right? So altogether, there are only 3 solutions. All right, the 3 solutions, they are 53.13, 180 minus 53.13, and also the 270, all right? The others, they are out of range. The next question is very similar, right? We have 6 cosine square x is cosine x plus 5, right? So you can have 6 cosine square x minus cosine x minus 5 equals to 0. So once again, we can do the factorization, or we can use the calculator to get the answer. But I think it is something like this, all right? So we have cosine x is minus 5/6, or cosine x is 1, all right? So once again, you can do this on the calculator. When cosine x is 1, x is 0. And there are 2 more extensions of the answers. It can be 360 minus and 360 plus for cosine, all right? 360 plus or 360 minus, all right? Minus 0 plus 0, the red answer from the calculator. And over here we have, x equals to minus 5/x is like 146 degrees, right? Or the extension answers, they are 360 minus or 360 plus, all right? 360 plus obviously is out of range, is too big. All right, so we only keep some of these answers. Let's see, what do we keep? We keep the 146, right? We keep the 360 minus 146. These are within range. We have 0. We have 360. But hey, do you keep or do we reject 360? We have to look at the range, right? That's why the range is becoming very important. Now, if you notice here, it does not include 360 in the range, all right? So 360 is not within range, so it is not accepted. After all, there are only 3 answers to this question, right? So let me recap again. The range here becomes very important, all right? Because when the number is on the boundary, right, it's 0 or 360, whether to keep or reject the answer depends on the range. So finally, we have this question, right? In this question, the difficult part is that we have cosine and sine, 2 different functions. So we have to make use of the trigonometric identities that sine square and cosine square equals to 1, right? We change this cosine square into sine square, 1 minus sine square, all right? And then we just copy the rest of the equation equals to 1. In other words, we have sine square x plus sine x is 0. So sine x is 0 or sine x is minus 1. All right, sine x is 0 or sine x is minus 1. All right, both are special angles. So at this point, I guess you have quite some understanding about this. X will therefore be 270 from here, only one answer. Here you got 3 answers. X is 0, 180, or 360. All these will give you sine x equals to 0. So now it's time to look at the range, right? We take all the x bigger than equals to x, equal to 0, right? Bigger than equals to 0. The 0 is included, but it does not include 360. So this, and this, they are acceptable answers, 0, 180, 270, but not 360, all right? So after all, there are only 3 roots, all right? So it is not just the equation not just the equation, but also the range is also important in deciding how many roots are there. Alright, so these are some of the past paper questions about number of roots in a quadratic equation.